Okay, so in this video, I'm going to go over the destruction plugin I made for Godot. The first half of the video is just going to be a tutorial on how to use it and how to add it to your game. You'll need the C# version of Godot, but you won't need any C# knowledge to actually use the plugin. And then in the second half, for people who are interested, I'm going to just scroll through the code and say what the logic is and why it works. So first up, just go to the GitHub and download the code. You can clone it or you can just download a zip. So I'm just going to download a zip now and then open it in Godot. Okay, so I've just gone ahead and loaded up the Godot thing. I haven't done anything to it yet. The first thing you'll notice is that these are just rigid bodies, but these are actually meant to be destructible nodes. So we'll have to go to plugins and enable it. Oh, okay. Actually, we don't do that first. I think we have to build it because it's C#. And then we can go to project and enable it. And then it should work. So now I make the scene tree a bit bigger. And also hide these. There's 3 things here, and they're all destructible body 3Ds, which is like the main thing that this plugin adds. So, so I'll just go through like this example scene. So the first node is just something we'll come to later. You don't really need to worry about that. It's optional. The next 2 are just the normal things that you have in Godot scenes. Then we have a bit of a camera, so I'll just load the scene. You can like go around with WASD and move the mouse. So then we have just a static body for the floor, and then we have the 3 destructible objects. So there's a big cube, a small cube, and then also a slab. So the slab's there because I wanted to show that you can split objects in half. Like it detects that things are not connected anymore. And then we also have this final node here, which is an explosion. And I've noticed that the transform's wrong. Let me fix that, but that's fine. So this is an explosion, which in your game is going to be something like an RPG or a grenade. And you're going to, if you want to use this plugin, then you need to add this type of node, which you can just Control A and add in. Okay, it inherits from Area 3D, and this is what's going to interact with our other nodes to actually split them up based on detecting if they're within the Area 3D. So in order to like play around with this plugin, if we go to debug and then turn visible collision shapes on, it becomes a lot easier to see, and then hit F5 and then wait a bit for the plugin to load. So now we can move about. Oh, and you can click Control to move faster. And we have this general explosion area. This is what this Area 3D represents as our explosion. And then if we hit H, you can see that parts of those bodies which were inside this sphere were split. And then you can press it again and it'll happen again. And then you can press it again and it'll happen again, etc. And then you saw there were like 10 dropped frames there because it was trying to make like 500 nodes or something probably. So you might not want to do it indefinitely. And then also there was it pushed the fragments a little bit, just using it just applied an impulse to them, but you can turn that off if you don't need it. So we can kind of forget about what's already in this scene and set up a new explosion so you know how it works. So if we, maybe let's just hide this, hide these things, and also hide this explosion. And then I'll just go to the top level and then I'll Control A and then destructible body. And the first thing you do is just like any other rigid body. So you add a mesh instance. I'll stick with cubes now, but there's no reason it wouldn't work on anything else. It doesn't work on concave objects, but I don't think that matters for most people because concave objects normally only for static bodies anyway. So you can add a box mesh, or maybe make it 5 by 5 by 5 or something. And then we can go to the normal mesh, create collision shape, and make sure this isn't tri-mesh because it won't work. And then we can rename this using F2, just a cube. And then move it over here. Okay, actually, I'm just going to delete these because I don't want them to get in the way. Okay, and then we can snap it to the floor. And let me make this less annoying. Now, there's a few things you have to do. So the first thing is an export. I might change this actually in release, but it probably will be this. With the mesh instance, just click the mesh instance there. And then a fragment container is just going to be, it's just for organization really. So you can debug things when you can click on the remote tab. So you could see where all your fragments are. So I'm gonna Control A and make a node and call it fragment container. Okay, and then add this cube to the fragment container and then specify the fragment container to be that, but it doesn't really matter. You can add it to be anything. I'm gonna turn off has textured material for now. We can come on to that later. And then tree height we can set just to be 8. That's fine. So now we basically have this destructible body within our scene, and we can load the scene, but we can move around. And there's this, but this is just a rigid body. It doesn't do anything at the moment. It's initialized as a destructible body, but we need some way to actually destroy the object. Okay, so the next thing to do is to add an actual explosion or something representing our explosion. So we need to add just anything for now. It can be a node or a node 3D, doesn't really matter. And then I have this script here called example explosion. We can read what that does. You don't need VS Code or any C#, any way of like editing C#. This is super simple. So all it does is if you press splitting explosion, or you could rename it if you go to the input map. So here is H. If you press that, then it activates the splitting component, and basically whenever you want to represent an explosion, this is what you need to do. This is like the only thing you need to actually code. You don't have to use C#. You can call this from GD script. That's definitely possible. It's in the docs. And you don't have to worry. This here is just because you can await this if you wanted to, but it doesn't really matter. So the point is that if you need, this is the only bit of code that you actually have to implement yourself, is something that actually calls the explosion, and the method that you need to call is activate. So then we've exported a splitting component, so we can go to the scene tree and add splitting component. So this is going to represent our explosion, and it's going to represent it on 2 different scales. So there's going to be a large explosion, and then there's going to be another smaller explosion closer to the center. So what that means is that things closer to the explosion are going to shatter off into smaller fragments. So it just looks a bit better. So we need to add 2 meshes, and they actually aren't used as meshes. They're just used for visualizing distances. So make sure they're both spheres. Maybe this is like a weird way of doing it, but it made sense in my brain. So it's just going to be the radius is the only thing that matters, but maybe let's make it actually look okay. So we have this. This is going to be the large explosion, so we can rename this as large. Okay, and then in our splitting component, we can assign it as large. And then we're also going to need another mesh instance. We can call that small. And then we can add another sphere mesh again. And then maybe make it like 3 and 6 or something. And then, yeah. So now we've got 2, we've got 2 meshes. And then the bigger one you want to make into a collision shape, because that's what this is going to use to check overlappingness. And then it's going to further check if the objects are within the radii of these 2 meshes. So I suppose I could just replace this with like 2 exported floats, but it made sense to me to be able to visualize it with meshes. And then we can export that one. And now this is the, actually I'll come back to this in a second. So if we go back to our destructible object, I didn't talk about this tree height. So basically on ready, the plugin is going to make a binary tree with like this as the tree height of the binary tree. So if we have 8 here, which I recommend, seems to be about right for most things, is we're going to have 2 to the 8 fragments possible that could be made, or combinations of any of those and their parents. And then in our splitting component, we're going to have the first explosion on the bigger scale is going to go down to, oh yeah, this is kind of cut off, but this is the deep one and this is the shallow one. So the first one's going to be shallow and it's going to be the larger explosion and it's going to go down 2 levels. And then once that's finished, we're going to wait 1 physics frame and then do another explosion on a smaller scale and go down another 2 levels. But you can change this to be whatever you want. So if you wanted, yeah, maybe you wanted it to only break down 1 level, and then down here you could put this to like 10 if you wanted, and then you'd get really small fragments closer to the explosion, and then just like 1 split on a larger scale. But this would probably like drop loads of frames, so I wouldn't recommend this. So yeah, we can maybe set it to like 3, no, yeah, 3 and 3, it doesn't really matter. So the deepest, the closest bit to the explosion will go down to a level which is the sum of these. So even if you set the deep one just to 1, it's still going to be deeper in the center than it will be on the outside. Okay, so that's basically it. And for setup, hopefully that made some sense. So now we can rename this to explosion, and then we also need to add the code, and then also add the exported variable, and then we can make this overlap with our destructible body, and then we can maybe make these invisible and make sure visible collision shape's on, and then we can run the scene again. Okay, and then we can press H and hopefully it works. Yeah, so it did. Okay, and then because this object's quite big and it kind of just doesn't really look like it's done anything that special. I mean, it looks like it's just fragmented the whole thing, but if we press it again, you can kind of see like that fragment's really big and that fragment's really big, but then here the fragments are a lot smaller. And then you can press H again, and because yeah, okay, that's another behavior I should probably explain. So because this tried to explode something that, like, it tried to go to a level which is deeper than the actual depth of this, then it Q3'd the object, because that made sense in my brain to do. But you could also turn this on and then it would make some particle effects. Or you could just change the code and not Q3 them if you didn't want to. Or if people really don't like that behavior, I can add a flag or change it or something, but I think it's fine for now. Okay, so we can change the cube to be something else, like I was saying earlier about the slab. So we can maybe make this like, I don't know, 100 meters long or something. Maybe that's a bit excessive, but, and then recreate the collision shape. Make sure everything's correct. And this probably won't produce any like, oh yeah, maybe we should make this, no, yeah, we should make this not as big, because otherwise it is just stupid. Okay. So we can do something like this, and then delete the collision shape, and then remake the collision shape. Okay, and then, yeah. And then I'm going to rename this to slab, and then realize that I should make it longer. Okay, yeah, that's a bit better. Okay, so now we have an explosion that's going to like cut this in half, so we can run this again. And then press H, and like, yeah, the point is that this isn't connected to this anymore because the plugin's detected that like we've removed these 3 fragments from the binary tree, And then the top level is like duplicated itself into two things. But maybe that's too much detail. But the point is that it correctly detects if fragments are adjacent and have share faces and should be one body, or there should be two bodies. And in this situation, we'd expect like this half to be separated from this half, and it correctly does that. Okay, so hopefully that's explained how to use it, how to use the example scene. The only real difference in an actual game is that obviously you wouldn't have this being what causes your explosion. You'd probably want an RPG, or or if you had a grenade, you want like a timer. So I can just like pseudocode out what you'd do. So you'd probably like export. You could do this in GD script, obviously, if you wanted to. You'd have some. Oh, actually, yeah. So if you maybe you would do, let's call this like RPG or something. Okay, and then you'd go here and you'd say like, yeah, you'd make. So let's say this is some rigid body which represents your projectile, like your explosive object that's gonna explode on impact. Then you'd have your like physics process. Okay, and then there's like some delta here or something. Cannot type. Okay, and it should probably have a double there. Okay, and then you're just gonna do like if RPG dot is colliding. I can't remember the actual function, and then you can do like this, right? So you'd probably want something like that, or if you had a grenade instead, you'd probably just start a timer in the grenade's ready function, and then once the timer's up, you'd call the same function. And then, yeah, you'd need this splitting component to be a child of the RPG or of the grenade, so it moves with it. But hopefully that makes sense. Okay. So hopefully that explains how to use the plugin in a game and how to use the example scene. Oh, also I should say what this is. So this is a node. Just you can control. Yeah, you can control A for it again. But what it's going to do is I'd recommend having all your objects, all your destructible objects, as a child of one node, and having all the direct children to that node only be destructible objects. Because let's say, let me duplicate this. Let's say I have like 5 objects, and like maybe I have a tree height of 10 on one of them, and then I have a tree height of 3 on the other, and then like 2, and then like, I don't know, maybe this is something and it needs to be 12. Okay, now if I try to run this, it's probably going to take like ages to load. Okay, maybe it might take crazily long. Maybe you decide that you want that in release, and that's fine. But for debugging, like, I'm already bored. This is far too long just to be able to test something which might not even be something to do with destruction. Okay, that was like 15 seconds. It wasn't that bad, but it took quite a long time. So this, let's use this one. This just depth manager. If you, this node that I said should be the parent for all your destructible nodes, if you put that as the exported variable, then you can turn debug mode on, is default off, but if you turn it on and then put it to like 2 or 3 or something, then run the scene, it'll just instantly load because it's overwritten all of these destructible objects to have a tree depth of only 2, so it can just load really quickly. But you haven't lost like any of your exported variables here. So then you could just turn debug mode off and then it would run again. So yeah. So it's just like a component that can help you when testing and making your games. You don't have to load in destructible objects and every single time. And you don't also don't have to go through every single destructible object and change this one exported variable. Okay, and then the very last thing is textures. So I'm gonna go. Didn't include any textures because I didn't want to bother with having to explain like LFS and everything. But I'm gonna go get 2 textures from Polyhaven, and then I'll be back. Okay, so I've added 2 textures. One that looks. Let me see if I can show it. One that's like, I don't know what it says, concrete tiles. I don't know, something random. And then another one that looks a bit like something that's been destroyed or something. The colors don't really match, but it's just an example. So let's delete all of these. And then for the nice looking texture, we're going to want to add that as just like you would normally to the texture of the mesh instance. So we can make new standard material and then go to the albedo and then put this in as the texture. Okay, and then it looks like that. And then we can go to fragment material and create a new standard material again and do exactly the same thing but for the rock. Okay, and then it looks a bit destroyed. Or maybe I'm going to use that. Okay, and then it's colored. Yeah, I don't really know anything about assets. But yeah, so we've done that. And then we're also going to want to go to hide that and then click has texture material to be true. No, that's not it. Okay, yeah. Oh, okay, so that was some texture pop. I think that's probably a bug in the code, but I'll try to fix it before I release the plugin. And then you can see that. Oh, I think it's because the standard material isn't putting the texture on to scale, but then the shader I'm using is. Okay, well, maybe someone knows how to fix that, but yeah. Okay, yeah, maybe there's some material option. Someone can tell me what it is that I'm doing wrong. But then the interior is the fragment texture and the exterior is the mesh instance's texture, or the original one. And then you can, yeah, well, those got destroyed, but yeah. So then there's some texture support, which isn't really working perfectly, like I just showed, but it's something. And maybe I can fix it soon. Okay, so now I'm gonna open the code and go through generally what's happening. There's like too much to go over everything, but I can talk about things on a high level. So if the main thing is the structural body 3D, okay, like that's what's doing most of the work. So, and this code is just like most of this behavior is just a C# port from cdaemon's Destronoi code. So like the first thing I want to talk about is just a copy from it. So in our basically the okay, well, let's go back to the top. So there's loads of variables which we'll get to. There's this parameterless constructor which Godot just requires for some reason. And then there's this parameterized constructor which the plugin uses, but we'll get to that in a bit because this is how we create Destronoi. This is how we create destructible things at runtime. But then we also need to create the binary tree for the fragments that are in the scene tree, like the ones that we've added manually. We need to create the binary tree. So the first thing we do, there's like a lot of stuff, but we create a VST node, and VST stands for Voronoi subdivision tree, as named by I think one of the papers that cdaemon read, or cdaemon themselves. And yeah, so we create a new VST node, which is going to be the root node of the binary tree, and we pass in some parameters. Basically, there's nothing important here other than the mesh instance, because all the other information doesn't make any sense for the root node. So we pass in like a duplicate version of the mesh instance, and then tree height number of times we split that mesh in half in some random way using this bisect function, which finds 2 points within the mesh, and then a plane which is exactly halfway between, and then produces 2 fragments. And then we iterate that on each fragment. So we're going to end up with a binary tree, basically. And then you don't have to worry about this if, like, it literally just plots some random sites. So it plots 2 things and then bisects the leaf in half according to those 2 points. And then we do some other setup, like we set the mass. We find the density, and then we do this thing because my code can also do reverse fragmentation because my game is like has reverse time stuff. So it's in there. You can try to get it working if you want, or if people really care about it, then I'll do another video. But and then yeah, there's some other things, and then also we like pass stuff to the shader if we're using textures. But this is like all a bodge. This is not a great way to do things, but I'll show you the shader in a bit. Okay, so once we've done that, we basically have a binary tree. And the whole idea of the plugin is, let me get a visualization of a binary tree. Okay, the whole idea behind the plugin is, let's say this is our binary tree, so we'd have a depth of 3, okay? And our plugin has created this, so this 0th level, as it were, is going to be the whole of the mesh, and then this level is going to be 2 halves, which put together would make the mesh in node number 1. Then on the 3rd level, it would be 4 quarters, and then it would be 8 eighths, okay, etc. So in a way, each level of this is exactly the same information. Okay, if you were to combine all of these meshes, you'd get the same object in any level. So if you combined 4, 5, 6, 7, you get the same mesh as if you combined 8, 9, 10, 11, 12, 13, 14, 15. And it would be the same as 1. Okay, so what CDemon's code did was just take 1 level of this. At least I think it did. It just took 1 level of this and then deleted the original node and then just created, like, for example, 8 eighths, all of the same size. But my idea was we could test that level for inclusion in some area 3D, because the CDemon's code does, like, the mesh instances still have a global origin, and we can find if, for example, node 10 and 11 are within an area 3D and maybe 12 and 13 aren't. So then we just remove these 2 nodes from the binary tree, from the original mesh. So it means that we don't have to remove every single fragment from a binary tree. We can just remove a select few and then work out what the rest of the mesh should look like, which is basically what the code does. So that's kind of the main behavior. There's loads of other stuff in this code. Like this is the bisect function that's doing clever stuff that I don't understand, that you should thank CDemon for. And then I have some like helper functions to create new fragments and stuff, but there's no like amazing logic here that's very enlightening about what's being done. The main other thing is this splitting component, okay, code. So this is what I said earlier. This is gonna represent the explosion. So this is the function that we call, and there's some debug prints here, but there's actually only 3 lines that are relevant, and that's explosion, and then we await 1 frame to create those fragments, and then we do another explosion, like I was saying earlier. Ignore this material. I don't know what it's being used for. Should just be deleted, but it isn't. Okay, so we can go to explosion, and like I said earlier, it finds overlapping bodies, and then does another explode function, which we can go to. Okay, and then it tests some stuff for particle effects that you don't need to worry about for now. Okay, and then it gets fragments to remove, which is what I just said. So we're passing in a tree depth as one of the variables, and then also a maximum distance from this area 3D that those fragments could be in order for them to be removed. And then it gives us back a list of things that we're going to remove. Okay, and then it does two things. So you can go back to our visualization. Let's say we do our test and the area 3D is like here. So we're going to remove 4 and only 4. So we kind of cut this branch here. So this reference in our binary tree, we just make null. And then 4, we look at all the children and we go, okay, none of the children have changed. So we can just, the mesh, which is number 4, we can just create. Okay, and that's what create small fragments does. And then we do some more early return stuff, which isn't enlightening to the logic. And then we do create parent fragments. And I can describe what that does as well. So once we've removed 4, we've got like these nodes are the remaining nodes that we need to like work out what they're going to look like. So we've just removed this fragment, and the only meshes we actually store are like the whole mesh and then 2 halves still, and then 3 of these quarters. So the first thing we can realize is that if we were to combine these meshes, so meshes 10 to 15, we'd get the correct object. Okay, that would be 10 to 15 minus these 2, and so we could create that as a body just using these. If we combine them somehow using some function that we'll just pretend is magic for now, but we'll come on to, and that would be the correct behavior. But that's not an amazing way to do it, because maybe you want a tree depth of like 12, in which case you're going to have like 4,000 of these to combine, which is ridiculous. So what we can realize is that number 3, because none of its children have changed yet in any of the behavior, because this is the first explosion we're doing, number 3 accurately represents the sum of all its children, and same as 5. So we can actually just combine 3 and 5 and we'd get the correct object. So basically when we cut this, we have to like recursively go up parents and say, okay, 2, you now don't accurately represent all your children anymore because we've just removed 1 of your direct children. And also 1 doesn't accurately represent all its children anymore because 2 has just changed. But 5 and 3 are unaffected. So they still have like a flag set to true, which means we just have short circuit behavior, and we don't have to, like, when we're combining meshes and working out what the parent fragment, as I called it, should be, we don't have to keep going down to any more children because we know nothing's changed below 3 because we check a flag. So that's what create parent fragments does. And it also does another thing, which I'll explain using this. So it also checks whether all of the fragments that we're going to create, so 5 and 3, are adjacent, because it could be that removing node 4 splits our object into 2 different sections, like the slab I showed earlier. Like that, node 4, the binary tree doesn't contain, like, the structure of the binary tree doesn't necessarily reflect the, like, spatial structure of the object. You could find it by testing loads of stuff, but it would probably be really complicated. You can't just look at a binary tree and go, oh, 4 is adjacent to 11. You don't know that. So we have to test using code in this case, if 5 was connected to 3. So if we go to create parent fragments, and then there's this function which does get spatially grouped nodes, which kind of does what it says on the tin, and it checks that if it groups it returns a list of lists, which is maybe a bit cursed, but the point is it returns a list of nodes which are grouped spatially. That's how you should think about it. And it takes in just a big list of ungrouped nodes. And it does this by this adjacent estimator, which just grows the 2 AABBs, which is like not an amazing way of doing it now I think about it, but it kind of works. Actually, maybe it's better to use this one. That might be true. Okay, maybe someone can decide what the best way is to do this, because I was just using this without thinking. But this is equal to like 0.05. So it just grows the ABBs a slight amount and see if they overlap, which is like obviously not actually a test for adjacency at all, but it's like 5 lines of code instead of adding like 500 to determine like complex adjacency between faces. Like I couldn't think of a way of doing it without just estimating it using a function like this or something like this that just tests if like the AABBs are capable of overlapping. Oh yeah, I think they actually do exactly the same thing. Yes, I think they do. So it doesn't matter. This maybe is slow. I don't know how fast grow and intersects are, but it's probably not the main bottleneck anyway, so I don't think it matters. But yeah, I couldn't work out a way of testing for adjacency that wouldn't involve like storing loads of faces and testing on normals, and then storing even more information in the binary tree on startup. So I thought this was fine, and I very, very rarely see it go wrong. And when it does go wrong, it goes wrong in a way that like no one would ever notice. So because it's going to group things that are close by anyway. So it maybe groups stuff that don't share faces, but they're going to be close by, and they're probably going to be small fragments, because that's the nature of the plugin. So yeah, okay, and then yeah, that's basically what the destruction does. And then there's loads of helper functions that basically everything else in this class is making sure that the binary trees are correct. So we have to update the original binary tree because we've just removed stuff from it. And then we also have to pass through copies and like subsections of the new binary trees to new destructible bodies in a way that like doesn't break things. And then I made it far more complicated for myself by wanting this VST unsplitting component, which does reverse fragmentation. So then I have to be able to like undo all of the stuff I've done on the binary trees. So then if we go to VST node, oh, doesn't exist anymore. Oh, it still doesn't exist. Okay, if we go here, we have like left and right references on our binary tree, but then we also have permanent left and permanent right references, so I can like reset things. And actually there is a reset function here that resets binary tree. So then you can unfragment stuff into like the parent fragments. And then, yeah, there's some other functions that like interpolate stuff so it doesn't look too unlike a reversed explosion. But yeah, I won't talk about that too much. And then, yeah, that's basically the whole code. And that's generally how it works. Oh yeah, and then there's also this, all like I said earlier about like this magic function which combines meshes. So there's this mesh pruning static class, which does basically just that. But then also for if things are textured materials, it has to worry about UVs and combining UVs correctly, or maybe not 100% correctly, but somewhat correctly, so it looks reasonable. But the main thing this is doing, if we look at combined meshes, it's looping through lists of mesh instances and then adding all the vertices into a new object and then returning it. And that gives us like loads of extra faces inside the body, but it doesn't really matter from what I've seen. It seems to be fine. If you didn't need that in your code, then you can just uncomment this line and then it would remove the interior faces. But sometimes that takes like really, really, really long. So I wouldn't, that's like, it doesn't change any behavior unless you would need that. I don't know why you'd need that, but maybe you do. So there's a function which does it. And also this combining face group UVs loops through faces, rather than surfaces or like groups of normals or something. So what that means is if you have like cylinders and you have a texture to it, or you have spheres, this will be like way slower than if you use boxes. So if you're going to texture materials, I'd recommend using boxes mainly, or things that don't have tons of faces. Or if you like, you don't want like 1,000 faces on and then texture it, it would just like take years to run. So you want this to be like 10 to 100 faces or something. Yeah, and then we can very quickly go through the shader, and so the C# code on the destructible body 3D on ready sets up this. So it passes in the interior surface material and the exterior surface material, and it gives us all the normals which correspond to the exterior faces. It's called surfaces here, but maybe that has some meaning in code, but it's checking against faces. And then we can ignore the first bits because they're quite readable. It basically, this code in this fragment function is going to loop through all of our surface normals and check whether the normal for this fragment is really close to one of those normals. And if it is really close to one of those normals, it's going to draw from the exterior material. And if it's not close to one of those normals, it's going to draw from the interior material. So this is like the fragment material, and this is the mesh instance material that you would set and can see in the editor. And then, yeah, and then it just draws them. And it also times it by like some custom color if you set your material to have some custom color. But, yeah. So that's basically all of the code and how it works and what it's doing. I hope that made sense. And I hope it can be useful to someone doing something. And yeah, maybe you can see something I've done that's stupid and doesn't work, or you encounter some bug that means like you can never use it. In which case, just let me know. You can open a GitHub issue, or you could comment on this video, and I'll try my best to get around to it. And there's also some issues that I've already made that would be like nice to have features that like I don't need in my game at the moment, but I could see would generally be useful for people. And there's also some stuff on the README about like general stuff that could be added, but isn't necessarily like a bug. So yeah, hopefully that made sense. And if it didn't, let me know.